Hello students, let us start with the next module of this chapter, matrices. Here we are going to continue with basic elementary transformation. There were total of 6 basic operations, out of which we have already studied 2. Let us study the next transformation here. The example here is as follows. I have a matrix A with me as follows 0, 2, 3, 4 and the transformation which I have to use is R2 changes to 4 times R2. That means that the element of second row are to be multiplied by 4. So the new matrix which I obtain will be 0, 2 in the first row and 12, 16 in the second row. Symbolically, I can write this as Ri changes to K times Ri, where K is nothing but a constant. The constant should be a non-zero scalar, that is, it can be positive, it can be negative, but it cannot be 0. So multiplying an element of any row by a non-zero scalar is the third property. So I can denote it as follows. If K is a non-zero scalar and row Ri is to be multiplied by a constant K, then we multiply every element of Ri by constant K. Let us move further for the next property here, that is 4. The example given to us here is as follows. I have a matrix A, the elements are 0, 2, 3 and 4. The transformation which I have to use is C1 changes to minus 3 times C1. That is, column 1 is to be multiplied with minus 3. So after multiplying all the elements, I get the new matrix as follows. 0, minus 9 in the first column, 2 and 4 in the second column. Symbolically, I can write this as follows. Ci changes to K times Ci. So what is this property here? Multiplying an element of any column by a non-zero scalar. Here, the non-zero scalar is K. The statement can be written as follows. If K is non-zero scalar and column Ci is to be multiplied by constant K, then we multiply every element of Ci by constant K. Now let us move further for the next property. The example given to us here is as follows. I have a matrix A with me. The elements are minus 1, 2 in the first column, 4 and 5 in the second column. The transformation which I have to use is R1 changes to R1 plus 2 times R2. This means that I have to use minus 1 plus 2 times 2 and 4 plus 2 times 5. That is, elements of R2 are multiplied by 2 and then added to R1. So the new matrix which I obtain is 314 in the first row and 25 in the second row. This is the transform matrix given to us. Symbolically, I can write this as Ri changes to Ri plus K times Rj. The property is as follows. Adding scalar multiples of all elements of any row to corresponding element of other row, where this Krj is scalar multiple of any row and Ri is the other row. The statement for this can be written as follows. Consider K as a non-zero scalar, then K multiples of element Rj are to be added to elements of Ri. Let us move further for the next transformation. The example given to us here is as follows. The matrix A is given to be as minus 1, 4, 2 and 5. The transformation which we have to use is C2 changes to C2 plus minus 3 times C1. This means that column 2 is to be added with minus 3 into the element of column 1, that is minus 3 into minus 1 and 5 plus minus 3 into 2. The matrix which we obtain now is minus 1, 7, 2 and minus 1. This is the transformed matrix. Symbolically, I can write this as Ci changes to Ci plus K times Cj. Adding scalar multiples of all elements of any column to corresponding elements of other column. Here, K times Cj is scalar multiples of any column and the other column is Ci. I can read this as follows. Here, consider K as a non-zero scalar. Here, K multiples of column Cj are to be added to elements of Ci. These are the 6 elementary transformations which we have studied. Now, there are some important points to be remembered. Consider this example which we have taken previously. Here what we observed, if Ri changes to Ri plus K times Rj, then after transformations, Rj, here Rj is R2, remains same as that of original matrix. Similarly, we had also taken one example for column transformation. So what we observe here, after Ci changes to Ci plus K times Cj, after the transformation Cj, here it was C1, it remains same as that of original matrix. Now the next property which we have to note here is, after applying elementary transformation, the matrix obtained is equivalent to original matrix. It is not equal to, but it is equivalent to original matrix. And the new matrix is called as the transformed matrix. Now let us understand some important notes here again. Element of rows or multiples of elements of row cannot be added to elements of a column. That means Ri changes to Ri plus K times Cj does not exist. The only thing which we can use is Ri changes to Ri plus K times Rj. Similarly for column as well, we cannot use Ci changes to Ci plus K times Rj. The only thing which we can use is Ci changes to Ci plus K times Cj. That means row transformation, we have to use only rows, and for column transformation, we have to use only columns. Thank you.